Again. Hi everyone, my name is Paul Hilton. I'm a mission manager at Space Machines Company. This is a bit of an update on Space Machines Company, what our premise is, what we're looking to do, and how we're going. So, safeguarding space for everyone. Isn't that a great statement? So Space Machines Company is looking to make distributed systems and solutions for space security. Now, there's a couple of things that are underpinning the way that we want to be able to do space. We want to be able to do space at an industrial scale. So we're talking about producing lots and lots in order to bring the economies of scale to space to make it cheaper. I was going to say cheap, but it's not really cheap. It's just slightly lower cost than the way everyone else is doing it. We want to be able to have a vehicle that can respond rapidly to incidents on orbits. So we're talking about very quickly moving over to other space vehicles, and I'll tell you why in a second. But also the point of need. So being able to deliver help on orbit. If there happens to be a failure, we will come to you. So I like to start off by setting like the conditions and the big scary, the threat to space operations. But really at the moment, there's a couple of challenges in the space domain that we're looking to help with. That is a vulnerability problem, a resilience problem, and a deterioration problem. Now, the vulnerability problem is the big scary one. As much as maybe we don't like to talk about it, or sometimes we are talking a bit more about it now, space is becoming a warfighting domain. So space is completely across borders. It crosses every country, similar to international waters. And because of that, there is lots of infrastructure in space. And at the moment, when there is conflict on Earth, there is also conflict in space. There is lots and lots of defense spending. So I've got here in 2023, there was $59 billion spent globally in space control. Then there is a resilience problem. So as we put more and more infrastructure on orbit, the amount that we rely on space from the ground becomes ever and ever larger. So I probably don't have to tell the people on the call here that obviously Earth observation, weather, communications, GPSS, timing, which pretty much runs most of our economy. A lot of that infrastructure is in space. So when it's in space, it's really far away. It could be from 300 kilometers away to 35,000 kilometers away. So how are you able to get to objects in space, or how are you able to repair that infrastructure? There's really no way to do it at the moment, even to identify if something's wrong. The third piece is the deterioration problem. As our previous speaker just mentioned, there is radiation in space. Things just get old and they just gradually die. When they do, space becomes cluttered. So much the way that if you're driving around on a highway and a car breaks down, there's no one to move it out of the way in space. It's just going to float around there forever and become a bit of a pest. So we're not looking to do removal of debris, but there's a few steps before you get to the point of removing something. And that's something we think we can help with. So what's our product? So our product is Orbit Side Assist. So similar to, as I said, if you're driving on the road here, you might have NRMA, roadside assistance. We call it roadside assistance in space, hence Orbit Side Assist. So what this is this means if you're on orbit or you have some infrastructure on orbit, you're probably not on orbit, but if you've got some infrastructure, some satellites on orbit, and they have some sort of something go wrong, there's really nothing you can do about it. You can try to talk to it from the ground, you can try to problem solve, but really, who are you going to call, right? There isn't a number you can call up. If you break down on the side of the road here, you call NRMA. If you're a member, it's cheap. If you're not a member, it's expensive, but at least you've got someone you can call. When you're in space, there really isn't anything that can do that. Everything is flying around at 7 kilometers a second in all sorts of directions, and there's not much you can do. So what we're offering is a service where we can come over to your vehicle that's on orbit and basically provide a bit of an assessment. We can take images, we can use optical imagery or thermal imagery, and maybe move towards gathering other types of information using like LiDAR or radar sensors to try to diagnose what's going on with your system so that you can get back on track. And how are we going to do that? There's essentially two key technologies that we're working on. There is the satellite, which is probably for me, the more exciting part, but that's the main part. And then there's Solstice OS, which is our operating system. So starting with the satellite, the Optimus Viper is what we're calling our satellite at the moment. And it's really the first responder if something goes wrong in orbit. It is a roughly 200 kilogram spacecraft, 500 meters a second of delta V, if anyone knows what delta V is. Propulsion system is primarily ethane and nitrous oxide, 6 degrees of freedom, control. So we're talking about RCS, cold gas system, 10 arc second pointing accuracy. So some of the nerds will know what that stuff means, but essentially it's quite a capable spacecraft. It's got lots of sensors and cameras on board. We're talking multispectral sensors. As I say, get down to 1 centimeter resolution at a kilometer. And when I say 1 centimeter resolution at a kilometer, we don't really have much by way of a yardstick at the moment for what do things look like on orbit. Probably one of the most well-known companies doing this at the moment is HEO Robotics, taking opportunistic images of other objects on orbit. And we're finally getting to actually be able to resolve images of taking of space objects. The International Space Station is a nice and easy one because it's enormous. But if you've only got a small satellite, someone needs to get up close to you in order to be able to see you. And Solstice OS is just our command and control operating system. So operating one spacecraft, nice and simple. Operating a fleet of spacecraft, not as simple. This is sort of our command and control system that's going to be sitting on the back end. Now, at the moment, if I said I need an Earth observation imagery of this building, Sydney Observatory, taken tomorrow, if you give me a credit card with a couple of grand on it, I could probably jump onto one of 10 websites and task a satellite to fly overhead tomorrow and take a photo of it. That's the state of where we are now. What we're looking to do is to take that one step further, and instead of task a satellite that's looking down, is to task a satellite that's looking sideways. So can you task a satellite on orbit to go and take an image of another satellite? That's really what our service is. Eventually, once we have lots of satellites and an entire fleet, you would be able to log on and basically put a request in to say, I need an image of my satellite, and we'll be able to tell you how much that's going to cost and when we can have that image taken. If you want the image really quickly, it'll cost a bit more because you've got to burn more fuel. If you want to take your time, we can do it more efficiently. Okay, so how are we going so far? So first up, mission 1, rollout. So we launched this mission last year. This was a technology demonstration mission. On the left-hand side of the screen there, you can see our spacecraft smack bang in the middle. I can use this little pointer here so everyone else can see it. Right here. So this is on Transporter 9. That's our launch there on the right-hand side. Everyone loves a photo of a rocket. So that was our first technology demonstration mission. Unfortunately, the spacecraft, we had trouble communicating with it, so it's no longer operational. But that was just sort of us finding our feet. A bonus photo at the top corner. That's not part of our standard photo pack. That's just me in front of the sign of Vandenberg Space Force Base because I thought that was pretty cool. So mission 2 is the Space Matrix mission. Now this is a mission part funded by the Australian Space Agency with a grant that we won, which is amazing. It is a debris inspection mission. Those with a keen eye for rockets will note that is not a SpaceX rocket. So that is an Indian SSLV rocket, which is a dedicated launch that we're flying up. At the moment, the launch window opens 1st of September next year. So we're actually in the moment, we're about to start our assembly, integration, and test of that spacecraft. Now it's a debris inspection mission, so it's also a demonstrator, but it's to be demonstrating the ability to characterize and image floating debris in space. So it's really the first step in figuring out how you're going to remove something, is first being able to take an image of it. We've got a couple of partners with us. We do have a HEO camera on there and a couple other partners as well from Australia and from India. And lastly, I just want to have a quick mention of our Scintilla propulsion system. So obviously the ability to move around on orbit means that you need a propulsion system of sorts. At Space Machines Company, we have developed our own propulsion system in-house. Those who know their Latin well will know that scintilla means, anyone in the room want to tell me what scintilla is in Latin? It's Latin for spark. I had to look that one up again this morning. But essentially, this is our way of saying we are building the spacecraft as much as we can in-house. We're starting with the propulsion system. Our photo on the right there is from our propulsion test facility doing a hot fire burn. So it's critical to be getting around on orbit. It's about a 50 Newton engine, and we've been able to get quite a lot of relights out of that engine. And at the moment, there's no issues with it. It's just a test version on the stand, but that is a real video. If you jump onto our LinkedIn page, you'll be able to see the video of that hot firing, which is always good to watch. Sorry, this is the last thing I want to talk about. So at our facility in Botany, so we are based here in Sydney, out at the UTS Tech Lab in Botany. The image on the screen is a computer-generated image, but I assure you that room actually does exist. It was just finished being built just about 2 weeks ago. So we're in the midst of commissioning a new clean room, which increases the size of our facility from being able to build 2 spacecraft at the same time to be able to build 6 spacecraft at the same time. We believe, if someone's willing to correct me, I'm happy to be corrected, but we believe it's the largest clean room spacecraft manufacturing facility in the country. I'm pretty sure, but happy to be proven wrong on that, just based down here in Botany. So we really are talking about increasing the manufacturing capability of the country by building this infrastructure. We also have some fairly distant plans, and you may have heard announced at IAC, also with the AMRF, as per our last speaker, to potentially look at building a much larger spacecraft manufacturing facility out at Bradfield, where the new airport is going to be. And that's it. That's Space Machines. A couple of images on the left there is some of the manufacture of our first spacecraft. Thank you. Any questions? And does anyone want to show me how I can put the questions up on the screen so I can see if anyone is asking a question?
So far, there's none except for thank you for adjusting the camera. So I have a question.
Yeah.
So if you're building all these clean rooms, big clean rooms, so can other companies come and like rent space or ask you to, or is this mainly for building your own things?
It's for building our own things. We haven't had anyone ask if they want to come build our space. I do have someone who's coming to our space, our clearing space, to do a bit of an interview in a couple of months. But at the moment, we have plenty of space in the clearing room. So if anyone wants to borrow a clean room, go right ahead. Come and ask us.
Is that a thermovac I saw in
Back there at the moment, we're hoping to have one once the facility is fully up and running. In the same building as us, there is VXB has a small thermovac, only about this big though. No, the one in the render is almost the size of the Wombat. I don't think we won't be having a spacecraft level thermovac.
The VXB is just a vacuum chamber.
Oh, okay, just vacuum chamber, yeah.
Do you have vibration testing capability coming online at Botany?
We do. UTS.
Question.
Oh, yes. So do we have vibration testing? Thank you very much. Coming along to our new facility. We do hope to. I know our head of manufacturing, Kenny, has a few on his wish list. But also we've been speaking to UTS because we are based at the UTS Tech Lab. They have, I think, in the latest renovations, reinforced the concrete so they can put a bigger vibe table in. But I think that'll be in the plans for next year. At the moment, we'll be having to rely on external testing for the next spacecraft. So we'll be heading down to Mount Stromlo for our thermal vacuum and vibration, probably with Oztest. Any other questions?
Yeah, just quickly curious, as you mentioned that when there is a conflict on Earth, that would impact the space as well. So just wanted to know a bit more context, like what does that really mean, and what are the implications to be taken care of any of that scenario if that happens?
Yeah, right. Okay, I think that's quite a deep question, actually. So probably more of a geopolitical question. But we have seen geopolitics on the ground play out in space. So when countries are at conflict or a disagreement on orbit, it does play into how they're going to cooperate or not cooperate on orbit, which is why we have some countries building their own space stations. We have some existing space stations that not all countries are allowed to go and visit at the moment. So when we see things happen on the ground, they do play out in space as well. I suppose where we believe our technology can play a role in that is there are lots of capabilities that governments and defenses have on orbit for looking down at the Earth and communicating. And that's a very important infrastructure. And we have seen in recent times other spacecraft go up close to spacecraft that don't belong to them and be observing and monitoring and taking, basically absorbing information from them. And there is no ability to defend from that at the moment. So just think about if you had a really, really critical power station that powered your entire city, you wouldn't want other people who weren't friendly to be coming up, taking photos and poking around, at least not without you be able to look back and sort of see exactly what they're doing. At the moment on space, if someone flies up close to your spacecraft, there is nothing you can do about it. And you don't even know what they're up to. Thank you for the question.
No worries. Thank you for answering. Thanks.
All right.
Well, I have a silly question, and that's the name Viper.
Yes.
Why did you choose that? Many people would say that's rather a negative word.
Because the Viper moves quickly. That's a bit of a captain's call from Raj, our CEO. But I'm not quite sure exactly where he got that name from. But as soon as he picked it, he decided he loved it. And he is of Indian heritage, and he does find it difficult to pronounce the V in Viper. So after he picked the name, he wrote it down and then immediately said, "Why did I pick a name that I find it difficult to pronounce?" Which is hilarious. But no, so the first, we are rolling with our Transformers theme. We've obviously with the Optimus and the first mission being rollout. There's only a few words we can use though without being copyrighted by Hasbro, I think, or whoever actually owns Transformers.
There we go.
Yeah. We do have one question online, which is NRMA in space. What role in space junk do you think collecting possibly? Yeah, so at the moment, we don't have plans to put robotic arms on them, although I'm sure our next speaker could tell us a little bit about whether or not that could be possible. So in order to deorbit something, you do need to be able to go and grab it. A really interesting mission recently was the Address J mission, which was flown out of Japan, which is getting really, really close to a very large piece of space debris. And in the UK, they do have the active debris removal mission that they're funding at the moment at the cost of, I think, about £70 million. And that is a mission for a single spacecraft to deorbit 2 pieces of space junk. So that's really pushing the limits of, I mean, that's never been done before. Even deorbiting 1 piece of junk with a spacecraft hasn't been done before. So deorbiting 2 is going to be a huge milestone. So this is absolute groundbreaking technology. At the moment, we're looking at, you need to get close to something to see what the condition is before you can even think of going over and grabbing it. Because there's many ways to grab things, depending on how big it is, what material it's made out of. So first, you need a quick assessment. We can give you that quick assessment, and then someone else can come over and grab it and deorbit it for you. All right, I think we'll call it there. Thank you.
Thanks, Ron.